This is exercise 6.136, where we're given the sample mean and population standard deviation, and we're asked to construct a 90% confidence interval and a 95% confidence interval to estimate the population mean. Which interval is wider, and then identify the interval itself. And so we're given some information here that I'm going to identify and label appropriately. So we're told that they take a random sample of 50, so our n equals 50, and in that sample the mean price was $642.90, so our x bar is $642.90, and then our population standard deviation is $59.50. We call that variable sigma. And then to the left, I've written the basic formula that we've learned to use to construct a confidence interval for a mean when we know the standard deviation of the population. So the question is, where do we find that z star, which is called critical value? And I believe MyLabs Plus calls this z crit, something like that. Same idea. What it basically represents is, in a normal curve, z star represents how many standard deviations out from the center of that curve we need to go in order to capture the middle, in this case 90%. Well, if you're capturing the middle 90%, that basically means that you're leaving out 10%. Half of that 10% is in this lower tail, and half of that 10% is in this upper tail. So we can go to our table of critical values for the normal curve, and we can look in the body of that table of critical values, which can be found in the appendix of our textbook, if there's not a link available to it here. And we're trying to get as close to 0.4500 as we can get. Now let me explain why. Our table that we use for our class gives the area that is between the center of the normal curve and the end of the interval. And so it's really, in this case, giving us half of our confidence interval. So from the center to that end of the middle 90%, we should have half of that 90%, which is 45%. And so what we're doing is we're looking in our table to find as close to that 45% as we can get. When we look at our table, we find that we can get 0.4495, and there's a 0.4505. Well, 0.4500 is right in the middle of those. So the 0.4495, we notice, corresponds to a z critical value of 1.64, and 0.4505 corresponds to a critical value, or z, of 1.65. Since 0.4505 is right in the middle of those, we're just going to need to average those. So we're going to take those two critical values, add them together, and divide by 2, and that's where we're going to get our critical value of 1.645. So here I've loaded that part of the table that I'm using just for further reference. And notice again, we see a 0.4495 and a 0.4505. Well, that corresponds to a z-score of 1.64 and 1.65 because we're in the 1.6 row, and then those two values are in the columns that have a 4 in the hundredths place and a 5 in the hundredths place. So now we know that our Z critical value is 1.645, and we can put it into the formula I referenced on the previous page for that Z star. Our X bar then, our sample average, was 642.90. Our sigma was 59.50. And our sample size was 50. So this will give us a lower limit and an upper limit for our confidence interval. And so our lower limit we would find by taking 642.9 minus 1.645 times 59.5 divided by square root 50. And we get, I don't remember how it told us to round, but I'm going to round to the nearest cent, 629.06 for our lower limit. Our upper limit is found doing the very same thing, except using the plus in front of the margin of error, in front of the 1.645 times 59.5 over root 50. And we get our upper limit of 656.74. So we can say that we are 90% confident that the true mean, can't remember what this is about, blah, 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 is between 629.06 and 656.74. Now, if we were doing this with the 95% confidence interval, the only difference would be that now we're capturing the middle 95%. And so on our table, we're going to have to look for half of that 95%, which would be 0.475. And when we do that, we find that we get closest to 0.475 right here. We actually find 0.475. So our Z critical value, we're in the 1.9 row of the table, and we're in the column that has a 6 in the hundredths place. And then we would go ahead and compute the rest of our confidence interval using 1.96 instead of 1.645.